Hello and welcome to this video tutorial for Creo Parametric version 3. This tutorial will detail using the Swept Blend tool, which can be used for making the volute in the pump assignment. All the other features on the pump and motor can be modeled using the Extrude tool, the Revolve tool, or the Pattern tool. But the volute is unique in that it consists of an opening spiral where the outlet cross-section is much larger than the initial cross-section. And the only way we can achieve this in Creo is using the Swept Blend tool. So before I demonstrate this, let's have a good look at what we're trying to achieve. So in our workspace, we have the right top front datum planes in our coordinate system. I'll just turn those back on. We're going to use our coordinate system to define this datum curve. So this spiral datum curve will be used for our Swept Blend. We can then see our Swept Blend tool. So this feature I'm hiding underneath the Revolve and Sweep tool. And this is defined by two sections. So our inlet section, which is much smaller, and our outlet section, which is larger. Now the process I'm going to outline here is used for creating this feature. However, the dimensions I've used aren't real, I've just made those up. So you're going to have to interpret this as best you can for making the pump feature. Before you model the pump for your assignment, I would suggest creating this feature first as a separate part just to get some practice before you incorporate it with your assignment. So I'll open a new part. So I'm presented with a blank workspace here. Now the first step in making the Swept Blend feature is defining the trajectory about which the sweep will occur. So previously in our datum tab, you probably put in datum planes, datum axes, maybe some points. We're going to input a datum curve. So we'll click this drop-down tab. Under curve, we're going to input a curve from an equation. Now from your detailed drawings and measurements, you're going to have to interpret this into an equation. So we'll click curve from equation. Now we have this red reference tab. So we'll choose our coordinate system. So this is the coordinate system which will define our equation. We'll just select our initial coordinate system. Now we've got options to either use Cartesian, cylindrical, or spherical. We're going to choose cylindrical. And note, this is what's called a parametric equation. So there'll be a parameter that will vary from 0 to 1. We can now enter our equation. So I've just made these numbers up, so you're going to have to rework this equation based on your measurements. So t is our parameter. In this case, it varies from 0 to 1. And we'll keep our z as 0. Okay. And there's our spiral. So we can choose OK. And that curve is now located in our workflow. So now that our trajectory has been defined, we can click on Swept Blend. We're going to have to provide some references for this. So the first is our trajectory, which is our datum curve. So we'll select that. We can see here that our cross-section will be swept from this initial starting point along our spiral to this end point. But we need to define those sections. So in the Sections tab, we'll click Section 1 and we will sketch. This will occur at our starting location. So we'll click Sketch. We'll enter Sketch View. So what we're doing here is we're building a cross section at our starting point that will be swept all the way along our trajectory. So in this case, I'll just put in a circle, diameter 20 mil. Okay, so it's our first section. Now we have to specify a section at the end of our blend. So we can insert another section. The section location will be at the end, so it will occur at this end of our spiral. We can then enter sketch mode by pressing sketch, and then we'll draw another circle. So we'll make this 150. Press OK, and our swept blend's now been defined. So we have in the references our trajectory, this green spiral, sections, we've got our first and second section, the starting and end points. We can then click OK to complete the process. So this swept blend becomes another feature in our work tree, so we can now place other extrudes or revolves. So we could click extrude, we could click this outer face as a placement location, we can enter sketch mode, we can choose this outer diameter as references. We can then project those using the project tool. And then we can extrude that. Like so. So now you have all the tools you need to complete the pump and motor assignment. But as a word of warning, I would practice making this swept blend first in a separate part before you add it to your final assignment piece.